Pre-statistics. Solving linear inequalities in one variable. Lesson objectives. Graph inequalities. Solve linear inequalities. Lesson objective. Stated true or false. Number 1. -5 is less than -7. This is false because -5 is closer to 0 than -7, therefore -5 is bigger. Number 2, 6 is greater than -8. This is true. Positive numbers are always larger than negative numbers. Number 3, -2 is less than or equal to 2. This is true. A negative is always smaller than a positive. Number 4, -3 is greater than or equal to -3. This is true. -3 equals -3. Number 5, -7 is greater than or equal to -7.01. This is true because -7 is closer to 0 than -7.01. Number 6, -9.02 is less than -9.2. This is false. -9.02 is greater than -9.2. Number 7, 1/5 is less than 1/8. This is false. 1/5 is larger than 1/8. We can verify this by using a calculator and taking 1 and dividing by 5, then 1 and dividing by 8, and we see that 1/5 is larger. Number 8, 2/5 is greater than 16/40. This is false. Actually, 16/40 reduces to 2/5, and 2/5 is not greater than 2/5. Number 9, 3/4 is greater than 0.8. This is false because 3/4 is 0.75, which is less than 0.8. These problems all involve what we call inequalities. Some problems in algebra lead to inequalities instead of equations. An inequality looks like an equation except in the place of the equal sign is one of the symbols: less than, greater than, less than or equal to, or greater than or equal to. To solve an inequality that contains a variable means to find all values of the variable that make the inequality true. For any two real numbers, a and b, exactly one of the following statements is true. Either a equals b, a is greater than b, or a is less than b. This is known as the property of order. Inequality symbols. So the symbol here means less than, and some examples: 2 is less than 5, and -6 is less than -1. Less than or equal to is the next symbol, and 4 is less than or equal to 7, and -3 is less than or equal to 0. Next is greater than, and we have 9 is greater than 2. That's a true statement. -4 is greater than -6. The next symbol is greater than or equal to, and the examples are 8 is greater than or equal to 3, -2 is greater than or equal to -8. Inequalities and interval notation. In words, we can say numbers less than 3 as an inequality. That would be x is less than 3. This is what the graph would look like. And at 3, we have an open circle because that is not part of the solution. It can be less than 3, but it can't equal 3. The interval notation would be from -infinity. Remember, we start with our smallest bound and we go to the largest, and that's up to 3, but there's a parenthesis here stating that it does not equal 3. Numbers less than or equal to 3 as an inequality would be x is less than or equal to 3. The graph now includes 3. And interval notation, instead of a parenthesis, we have a bracket. Numbers greater than 3 would be x is greater than 3. The graph would look like this. Now it's numbers to the right of 3, but again we have an open circle here because it can't equal 3. And then with the interval notation, we would start with 3 and go to positive infinity. Parenthesis here for the 3 because it can't equal 3. And of course, anytime we have infinity or negative infinity, we can never equal it. So it's always going to be a parenthesis here. Numbers greater than or equal to 3 would look like this as an inequality. The graph now includes 3, so we put a solid circle on 3. And then the interval notation would be bracket 3, comma, infinity. Example 1. Write the inequality x is greater than negative 2 in interval notation and graph the values of x. Solution. The inequality x is greater than negative 2 means that the values of x are greater than negative 2. We describe these numbers in interval notation by parenthesis negative 2, comma, infinity, parenthesis. To graph the values of x, we shade the part of the number line that lies to the right of negative 2 and draw an open circle at negative 2. So this is what the graph would look like. So any number on this number line in blue will make this inequality true. English sentences and inequalities. X is at least 5. This is tricky because in inequalities this means x is greater than or equal to 5. An example you can think of to remind you of this would be you must be at least 16 to drive a car. That means you can drive it at 16, you can drive it at 17, and any age beyond 16. But you can't drive a car if you are less than 16. The next one, x is at most 5. This means x is less than or equal to 5. X is between 5 and 7. This is what we call a compound inequality. So this is saying x is greater than 5, but at the same time 7 is greater than x. So all numbers in between 5 and 7, x is no more than 5. That's the same thing as the inequality x is less than or equal to 5. And the last one, x is no less than 5, would mean x is greater than or equal to 5 as an inequality. Lesson objective. Definition. A linear inequality in one variable is an inequality that can be put into one of the forms. mx plus b is less than 0, mx plus b is less than or equal to 0, mx plus b is greater than 0, or mx plus b is greater than or equal to 0. This is where m and b are constants and m does not equal 0. To solve an inequality. You solve an inequality just like an equation. You follow the order of operations in reverse order by using the inverse of each operation. This is true except for two cases. When you multiply or divide by a negative number, you must flip the inequality sign. Let's look at why that's the case. So let's start off with a true statement. 40 is greater than 10. This is a true statement. Now, if we add 4 to both sides of the inequality, we now have 44 is greater than 14. Well, this is still a true statement. So let's take that true statement, 40 is greater than 10, and this time let's subtract 3 from both sides. Well, we end up with 37 is greater than 7. This is still a true statement. So we can add any number or we can subtract any number to both sides of an inequality and we are still left with a true statement. Now let's multiply. If we multiply this true statement by 2, we have 40 times 2 is greater than 10 times 2. Well, that becomes 80 is greater than 20, and that's a true statement. Again, let's take our true statement. This time let's divide, and if we divide by 5 to both sides of the inequality, we are left with 8 is greater than 2. Again, this is a true statement. So why do we have to worry about flipping the inequality? Well, let's start with our original true statement. This time let's multiply by a -1. This is going to give us -40 is greater than -10. This is a false statement. -40 is less than -10. So if we multiply by a -1 to both sides, we have to flip the inequality. Now let's do one where we divide. If we divide by -2 to both sides, we are left with -20 is greater than -5. Again, this is a false statement, but if we flip the sign, we are left with a true statement. So if we multiply by a negative number, or if we divide by a negative number, we have to remember to flip the sign. Thanks for watching.